Subscribe to this YouTube channel by clicking the subscription button below. For future webinars and online short courses, please visit our website at australianwaterschool.com.au.
Hello everyone. We're delighted to welcome you to this webinar to be presented by Dr. Arun Shrestha of ICIMOD about the water resources of the Hindu Kush Himalaya. I'm Dr. Susie Goldsmith and I'm guest chair today. It's great that so many of you have joined us today. As you see here, we have participants from across the globe and we're looking forward to your global perspectives in the Q&A session. This webinar is brought to you by IceWarm, and I just want to bring your attention to the webinars and courses that are available in the next month or so. You can find details and register on our website. We have an amazing opportunity today to learn about an issue of global significance. The Hindu Kush Himalaya contains 14 of the world's highest mountains. Known as the water towers of Asia, the region feeds 10 major river basins, and around 250 million people live in the mountain region, while nearly 2 billion people, or 1/4 of the world's population, live downstream. That's equivalent to the populations of China, Indonesia, and the US combined. Established in 1984, the International Centre for Integrated Mountain Development, ICIMOD, is a regional intergovernmental learning and knowledge sharing centre serving 8 regional member countries of the Hindu Kush Himalaya: Afghanistan, Bangladesh, Bhutan, China, India, Myanmar, Nepal, and Pakistan. The centre has a proactive focus on people, improving the livelihoods and prospects of those living in the region, and that practical focus is informed by strong science, and we're going to hear about that today. Of interest to those Australians attending today, Australia is one of the 5 core donors to ICIMOD, and our ambassador to Nepal chairs the ICIMOD support group. So it's my great pleasure to introduce Dr. Arun Shrestha, who is Senior Climate Change Specialist and Program Manager for ICIMOD's Regional River Basins and Cryosphere Program. Arun's joining us from Kathmandu. Welcome, Arun.
Thank you, Susie.
Arun, what do you find most fascinating about the Hindu Kush Himalaya?
Well, the physical dimension, first of all, the horizontal and vertical dimension and how it modulates the atmospheric circulation, and cultural and social diversity. I think these are 2 very important facts that fascinate me.
Yeah, that's great. It is just a huge question. We asked all of you attending today about your familiarity with the topics that we're going to discuss, and here are the poll results. And I don't know what you make of this, Arun, but obviously there's a lot to learn for all of our attendees, me included. There's a bit more knowledge of hydrology, less knowledge about the Hindu Kush Himalaya, and understanding of the cryosphere. Oh, to some extent, people are doing better than me. Yeah. So there's so much to learn, and it's completely over to you, Arun, to start your presentation.
Okay, thank you so much. Suji, I think you have given a very good introduction and overview of my presentation, so it becomes really easy for me to start my presentation. And thanks to everyone around the world who have decided to join this presentation, which is on state and fate of Hindu Kush Himalaya water resources. Looking at the poll, I think it is a mixed kind of group. So I think the way I have prepared my presentation will be okay. I think I have not put it very scientific, but I have put some good facts in it. So if you have any question, please let me know, and I will try to answer. Now, just to explain what is Hindu Kush Himalaya, basically this is an aerial view of Hindu Kush Himalaya looking from kind of like southeast. I'm just getting my laser pointer set. Okay, so what we are looking, this is the India basically, and this is Tibetan Plateau and China. The mountain starts here in Afghanistan, This is Pakistan, this is India, Nepal, and Myanmar, and this is Bhutan, and this last part is Tibetan Plateau. So as Suji has already mentioned, this is very impressive, geophysical kind of entity on the surface of Earth because of its vertical and horizontal, scale, and also the atmospheric circulation that, is modulated by this mountain system. This region is, dominated by monsoon system, which is southeasterly during summer and westerly during winter. And it is a great source of moisture, which actually sustains the cryosphere in this region, snow, ice, and permafrost. Hindu Kush Himalaya is also a global asset of food, energy and water, carbon, and cultural biodiversity. Now I'll talk a little bit more about all those things in my subsequent slides. This actually is the map of the region, and again, South Asia, Nepal, China, India, all are represented here. The region we work and what we call Hindu Kush Himalaya or HKH region is dark shaded here. And 8 countries actually share this region. Those countries are Afghanistan, Pakistan, Nepal, China, India, Bhutan, Myanmar, and Bangladesh. What is also important is that this mountain range supports, 10 major river basins of this subcontinent, which are represented here. What is also important is that 6 out of those 10 river basins are transboundary and is shared by more than 1 country. 240 million people live in the Hindu Kush Himalaya mountains, this dark shaded area, and then 1.65 billion people live in the whole river basin. That's quite a large number of population, and actually it's a quarter of the population of the whole world. What is also important is the number of people living there. I said 1.65 billion, but you can see where they are living. They are not living in the mountains actually, but they are living in the foothills, in the plains. So they are relying on the water that is coming out of the mountains. So, but what is happening is that all the decision related to what happens in terms of development, etc., is done by the plains, and it actually does not reflect what is happening in the mountains. What is also important is cultural and social diversity. This slide just indicates in a pictorial manner how different people are in terms of their outfits, outlook, complexion, etc. And this region actually houses more than 1,000 living languages. That also tells how important from cultural and linguistic point of view this region is. So all in all, what happens here is likely to affect 1/4 of humanity directly, but indirectly it could be much more than that. So now I'm going to talk about what is happening in the region in terms of climate, cryosphere change, as well as changes on water resources. So my, what I'm going to present here are based on mainly 2 main references. The first one is the Hindu Kush Himalaya assessment, which is a big, report that came out of ICIMOD earlier this year, and some statistics are given here. It includes very diverse chapters like climate, cryosphere, water, governance, gender, and many other things. You can download it by scanning this QR code. And the other is Himalayan Climate and Water Atlas. Both of those reports actually, synthesizes very high science publications in different scientific journals. Okay, so what is happening to the climate of Hindu Kush Himalaya? As in most part of the world, the region Hindu Kush Himalaya is warming quite rapidly, but comparatively, it is much rapid warming in this region. Now, I think you have all heard of UNFCCC negotiations and the discussion to limit the end of century warming compared to the pre-industrial period by 1.5 degree. And this slide actually shows what happens in the region, Hindu Kush Himalayan region, if the world manages to stabilize at 1.5 degree. Now, this one shows actually, if the world by some means stabilizes at 1.5 degree, the warming in this region in average will be 2.1 degree plus minus 0.1. Now, if it is this scenario, which is a moderate scenario, RCP 4.5, if the world goes by that pathway, then the warming is much higher, 2.5 plus minus 1.5. But then if the world goes as it is without much mitigation, it will be as high as 1.5 degree plus minus 1.5 by the end of century, which is quite alarming. So 1.5 degree is still too hot for Hindu Kush Himalaya region. And if we go by some specific region, it can be much higher. That is one fact. The other is that as we go higher up with altitude, the warming gets much more intensive. So this is called a phenomena called elevation-dependent warming. So higher altitudes is warming much faster. So what it means in terms of glacier melting? What does 1.5 degree average warming means? It means that 1/3 of all glaciers will be lost by the end of the century. Now, if the world goes by current emission scenario, then 2/3 of the glacier volume will be lost. So these are quite dramatic scenarios that we have now begun to understand. Similarly, snow-covered areas and snow volumes will decrease, and snow line elevation will rise up. Snowmelt-induced runoff peaks will be stronger and occur earlier in the year. So these are some of the consequences to the cryosphere. This also shows how different warming scenarios, climate change scenarios will result in glacier change. For example, I'm not talking about everything, but if it goes by 1.5 degree, these are various glacier change scenarios for different warming scenarios by end of the century compared to the pre-industrial period. For 1.5 degree, you can see about 30% is lost. So that is what we are understanding about the glacier change. Now the question is, what happens to the water that is coming out of the mountains from glacier snow and permafrost? For that, first of all, we need to understand how much water is contributed by snow, glacier, and permafrost, right? So this map actually shows the upstream part of Indus over here, Ganges over here, Brahmaputra, Salween, and Mekong river basins. And these three panels actually shows glacier melt contribution, snow melt contribution, and rain runoff contribution. And the color code actually shows how much contributions are. Green shows low contribution, and red shows very high contribution. And you can see from the graphics that Indus is heavily glacier melt dominated, whereas other river basins are not. Here, this part is Kabul River Basin, which is heavily snow melt dependent, but others are not. The upstream parts are, but not the lower part. But then all the other eastern river basins, Ganges, Brahmaputra, and Salween and Mekong, is largely contributed by rain. And this actually chart shows which river basin is more glacier melt dependent. So UIB represents Upper Indus Basin, which is 41% contribution is by snow melt, about 20% by snow melt. So total the snow and glacier melt is over 60%, whereas if you go to Upper Ganges and Upper Brahmaputra, it is quite less than 20% or 30%. So it already shows which river basin, in this case, Indus River Basin, is more influenced by climate change and glacier melting. This chart might be a little bit complicated to people who do not understand so much hydrology. So I will try to explain. These are called hydrographs, and these are months, January to December. And this is the amount of water flowing at certain particular point. In this case, it is Kabul, and these are different points: Indus, Satluj, Ghagra, and different colors shows contributions by groundwater, snowmelt, rainfall. Snowmelt, blue is rainfall, blue is glacier melt, and green is rainfall contribution to that. And there are two lines on the top, one representing current condition, which is reference period, and the other one is the future scenario, 2050 scenarios. Now, you cannot see difference between blue and red here in most of the cases because they are not that different. So climate is changing, glaciers are changing, but the hydrology is not changing. And the question could be why? And these are two different scenarios. One is moderate scenario and one is extreme scenario. The answer is because the rainfall pattern is also changing, the monsoon is also intensifying, and the glacier melt, reduction due to glacier melt is actually being compensated by more intensive rainfall. So there we do not see at this scale, annual and season scale, a big change in hydrology. But this is at larger basin scale, upstream part of the basin scale. But when we go really to the headwaters, the high mountain catchments, then there is definitely impacts are happening. For example, this I saw a glacier from Pakistan, Karakoram area of Pakistan, which is called Pasu, which was taken in 2009. And this is the same glacier taken in 2014. What I would like to draw your attention to is this part. This is actually a farmer managed irrigation system, and you can see it exists in 2009. In 2014, it is dry because the glacier has gone down and the irrigation intake is higher up, so the water is not flowing into the irrigation. So that's kind of impacts happening at really headwaters. That's one I would like to show. And this is another view of headwaters in Ladakh, which is very arid. The only water source is from meltwater. So the mountains are very dry on the valley, which is having irrigation from mountain like the one in Pasu is green. So anything happening to glacier water will be pretty, having pretty bad impacts in this kind of areas. Now, the other thing I would like to mention here is about the mid-hills. Hindu Kush is not only high mountains, it has also mid-hills, which is, these areas are not supplied by meltwater. Springs and hill groundwater waters are the sources of water. And here, drying of springs have been a big phenomenon, and that would be a big problem related to water. So at larger scale, basin scale, not big problem. In terms of water quantity, at headwaters there could be problem, and in mid-hills there could be problem. But another aspect of water is the extremes. It is not average flow, but also extremes. So we are already experiencing a lot of extremes related to water, and the projection is that in the future, the extreme events like flood and also droughts are likely to impact the people living here. And mostly we know that there are more vulnerable people and less vulnerable people, so more vulnerable people will be impacted, and these are women and poor people and marginalized people. And this slide actually shows how the extreme flows are likely to increase in the future. What is shown here is the 50-year return period flow of moderate climate change scenario and extreme climate change scenario. And again, the red shows by what a very high percentage, like 300%, the 50-year return period flood is likely to increase in magnitude. And if you look at in average, it is more than 100%, the 50-year return period is likely to flow. So that means, a flood having return period of probability of repeating in 50 years will have double the amount of magnitude, so that's the likely scenario happening. The other thing I would like to mention here is about glacial lake outburst flood. Because of glacial recession and shrinkage, in a lot of areas, the space occupied by glaciers are being occupied by water bodies known as glacial lakes. And these are very unstable environment, and they can break out due to various reasons. And that outburst is called glacial lake outburst flood, which can be very catastrophic. just one example of Nepal, and this is actually a hydropower dam, small size hydropower dam, which was damaged by a GLOF, very small glacial lake outburst flood originating from Tibet, but it damaged Nepalese part. You can see the extent of damage. This is a huge 8-meter concrete wall, which was supposed to be here. It was thrown out here, right? So this is likely to be another impact related to extremes. Now, what we can do, excuse me. So I have talked about challenges, but I think we also need to talk what we can do, because we cannot just remain at challenges. So in my opinion, it's a very complex situation, complex challenges. But if I were to, represent the how to meet those challenges in 1 or 2 slides, what I would suggest, the bottom line is minimizing the risks. And I have talked about the different kinds of risks: the GLOF, flood risk, drought risk, erosion and sedimentation is another thing which I didn't talk about. Landslides are quite prominent here. So minimizing the risk. So first, understanding what are the risks in the river basin, how the risks are connected across the scale, small scale to larger scale, and who are the vulnerable people who have to be taken into account. So first, understand the risks and minimize them. But then it's not only about risk, but also there are a lot of benefits in the river basins. So benefits related to drinking water for so many people, irrigation, biodiversity is quite rich, hydropower, and industry. So understanding what are the opportunities related to water resources, how to balance the water uses across the scales, and who are the beneficial groups, and manage them. So all in all, this calls for integrated river basin approach for minimizing risk and maximizing benefits. So in conclusion, I just wanted to leave you with some key messages. High warming rates with elevation-dependent warming, rapid cryosphere melt, water availability at a basin scale not likely to impact it, but problems in most upstream catchments and mid-hills. High uncertainty in the precipitation forcings for high altitudes and uncertainty in climate projection. I think we have to talk about uncertainty. There is a lot of uncertainty because we are in a very challenging and rugged topographic region. Limited good quality stream flow data for validation. High uncertainty in extreme is very important. So the future should be invested in understanding better the extremes, current understanding use. But however, I would like to, with all those uncertainties, I would like to stress that current understanding are already useful for making better policy decisions. We should not stop here and say that we need more knowledge, more science results to do anything. We can do quite a lot, but of course, improved knowledge will help better climate projection and detailed studies at small scale and catchment scale needed. And also, as I said, population is large, population is increasing. So how the water availability can meet the increasing demand? I think that is also very important. So these are some important messages I thought I should mention at the end, and that's end of my presentation. And thank you all for being here and listening to me. And now I'll be happy to take questions and hand over to Susie. Thank you.
Thank you for a great presentation, Arun. It's overwhelming, stunning scenery, overwhelming challenges, and so many puzzles still to unravel. Just the extra dimensions once you add a cryosphere into the mix. It's quite baffling. We have a few questions coming through, which is great, and so we'll get started, but I'll just maybe kick it off by asking you about, to share with us the concept that you've spoken of before to me about science democracy. We've got 8 member countries of ICIMOD. They're not, I ran through the list earlier, they're not renowned for being quiet and passive places. And I was just wondering if you could share a bit about this concept, ICIMOD's concept of science democracy.
Science diplomacy, I would say.
Okay.
Okay. And you have rightly mentioned South Asia is not very popular for cooperation across the boundaries. There are a lot of sensitivities. Geopolitics is quite strong here. And whenever it comes to water, there is very little sharing between the countries. But then, with climate change, there is a little bit of opening, because the countries feel they are getting vulnerable. So it's best to, cooperate a little bit, although there is not a big progress. So the approach ICIMOD is taking is through science. And scientists are more open for talking, collaborating, meeting, and sharing. And and that's what we call science diplomacy. And through scientific platforms, dialogues, and sharing, we believe the trust between the countries can be built. And in the longer run, there will be more substantial cooperation in solving those issues. So that's what I would say our approach. And we have different ongoing programs on Indus Basin. We have Upper Indus Basin Network and Indus Basin Knowledge Forum, which brings together scientists to talk about similar challenges they are facing and how they are trying to solve it, and different disaster platforms. Also, we have established in Koshi River program. Cryosphere is a very important and very interesting issue. It draws attention from a large number of people, and also we have a cryosphere hub where we bring people to talk about the basic science behind cryosphere, but also how it relates to the society. More and more, we are bringing the science to the society. So how the science can help them, and how countries are doing there. Is there some across the boundary learnings that can be used?
Yeah. Thank you so much. I think it's a fascinating question. Now, I've got a few questions coming through about the approach that you've taken. And one question is from somebody asking about the appropriate GCMs for this area and how many were used to project the scenarios that you discussed.
Right. Okay. Now, I mentioned, I think you have noticed that it's very challenging area. The topography is very challenging, and the convective system, the monsoon system itself is quite difficult for GCMs to actually provide scenarios which are very good. Actually, none of the GCMs are good at it. But we have to live with what we have in hand and try to improve on it. So therefore, the approach we have taken is not to take best GCMs which represents the climate of the region, but try to we go with this approach called envelope-based approach. Of course, the GCMs have to be reasonably good to reasonably represent the climate, the monsoon of this region. But since our exercise is, the whole exercise is to understand the impacts on water and extremes, we take this envelope-based approach, which looks at, more like extreme scenarios of temperatures and precipitation, and taking those extreme scenarios and see how the cryosphere change will happen and how the water availability change will happen. And that will give us a room to play in decision making. Even in worst case scenarios, this decision will likely to be helpful. So that is the approach we take. But it is an ongoing, effort to improve the climate scenarios and make it more high resolution, but also able to represent, processes like, for example, monsoons and westerlies in the region.
So it sounds like you're taking quite a risk-modulated approach. You're trying to look at what's going to help you with the impacts and the responses you need to develop. So someone else has gone a little bit further and asked about the hydrographs with the different water sources, so glacial melt, snow, rainfall, groundwater. They wanted to know how the hydrographs were separated into the different sources.
Okay. We are using, thank you for that question again. We are using quite detailed hydrological models which can, represent cryosphere processes quite, nicely. For example, glacier melt, snow melt, and also contribution from rainfall and groundwater, and quite a few of those. If you want the name, SPY, developed by Utrecht University, is one. The other one we are using is called J2000, which was developed by Jena University in Germany. So these are two most used hydrological models, which can actually separate out different components of the hydrology, not only for current period, but also for future period. So it has a little bit, not so refined, I would say, for the scale, because we have a very large scale of domain. So approximation is, of course, there, and assumption. So the glacial dynamics is also inbuilt with certain approximation. So it can also give, under changed glacial scenario, what will be the water availability from all those components, hydrological components in the future.
Thank you. And someone else has asked, in fact, it's Anthony Slatcher, has asked, are there any intergovernment processes for considering ICIMOD's reports and cooperating on responses? Do you think we are adequate in the future?
Yeah.
And I know there's quite a lot going on there.
There's quite a lot going on. One major intergovernmental mechanism is called SAC, South Asian Association of Regional Cooperation. And we have very common, quite commonality between countries in SAC and countries in ICIMOD, with members of ICIMOD. So SAC doesn't have China, but it has Maldives and Sri Lanka, so that all the rest of the countries are quite common. Mm-hmm. But since SAC is very government, dominated process, things happen very slowly, and if there is any sub-regional issues between two countries, then things don't move in SAC. So they have a very strict protocol. Whereas, ICIMOD is intergovernmental, but, it also does the science diplomacy. So that kind of platform I have mentioned about UIB network, Koshi DRR knowledge hub, and also we have different transboundary landscape where, it's a little bit less sensitive and people cooperate. And what we try to do is we try to come up with common messages, common challenges and common solutions, and we share with different government entities, government representatives, try to sensitize them about the issues, and also try to make them, kind of take some decision based on science output. So this is what we do. There are few sub-regional, entities coming up, like BBIN, that is the Eastern Himalayan, based India, Nepal, Bhutan, and Bangladesh, which is slightly diffuse in terms of geopolitics, and things can happen, hopefully, a little bit faster there. The Belt and Road Initiative, which is mostly China, but I think it has a big, influence area. It also creates a lot of opportunities to manage risks across the transboundary countries. So we take, advantage of all those things happening in this region and try to influence as much as we can from science angle.
Okay. Gosh, there's so many questions coming through. We're going to have to get a pace on, but I'm going to ask you a large one now, or I suspect it is. Rizwan Mansha has asked, this year, parts of UIB in Pakistan received huge amount of snowfall, especially Himalayas and Karakoram mountains. What's the prediction for snowfall in the Himalayas in the future? And I know you will talk about the Karakoram particularly.
Okay. Well, I did not catch the name, but thanks for asking. Mansa, was that Mansa, right? Okay, thanks for asking. And I wanted someone to ask this. Yes. First of all, climate change is not about monotonous, change, right? So when it comes to precipitation, it is in general increasing trend, but with a lot of extremes. It's not, gradual linear change, but it can also have, very low periods with drought, and some years very high intensive, precipitation. And in the mountains, it could be, heavy snowfall. That's one thing I would like to mention here. The other thing is particularly related to Karakoram. Now, in terms of glacier shrinkage, almost all glaciers in Hindu Kush Himalaya are shrinking. And I said almost all, because not all. Some glaciers in Karakoram are not shrinking, and some of them are even advancing, which is known as Karakoram anomaly because it is anomalous. Like the rest of the region is showing some behavior, but Karakoram is not. So what is driving that factor, the Karakoram anomaly? It's a scientific question. I will not pretend that we know. But the hypothesis is that the winter snowfall, which is brought by westerly disturbances, is likely increasing at the very high altitude. Not at the low altitude, but very high altitude. The westerly disturbances are increasing and bringing in more snowfall, which accumulates and, flows down and adds mass to the glacier. Not all glaciers, but some glaciers. Because we know, Karakoram is right there in the pathway of westerlies, and therefore, it receives high amount of snowfall. But then the puzzle is, in the same area, some glaciers are, of course, advancing, but some are not. What's happening? I cannot tell you why, but the hypothesis is there is something happening with the westerly that is actually impacting and causing the cryosphere anomaly. This is something which we really would like to understand more, and there is more and more, investments going on in terms of scientific understanding of Karakoram anomaly and westerly change and the climate change.
Thank you. There's so many conundrums. So Hari Krishna KS, I'm not sure what that stands for, has asked about, and this is another, perhaps a cooperation kind of question. Could you touch upon the possibility and challenges of building a real-time integrated flood forecasting system for the Hindu Kush?
Oh, that could be a long list, but let's go with the most important one. One is that, as I think it's clear now, the rivers are not limited to one country. So they flow from one country to another country. So to have a really effective flood forecasting system, you have to have, again, this transboundary sharing mechanism, which actually tells that if a flood is emerging from China, Nepal knows it in advance, and then India knows about it, and Bangladesh knows about it, right? So that kind of sharing mechanism is very important, which is still not there. We have tried to start something under the HYCOS Global Hydrological Cycle Observation System program. We can go to our site and search for HYCOS. There are some functioning, not forecasting, but flood outlooks are there. So for that kind of thing, that cooperation is needed, because you need real-time ground-based information for doing that kind of forecast. So without that, it is very difficult to do that. So one of the biggest challenge is sharing of data is one. But then in some countries, there's a big issue of capacity. For example, for real-time running the model and operationalizing, validating it based on ground-based data is another challenge. So these are two things. One is the sharing mechanism. Two is capacity, I think, are the most important thing. But of course, resources are needed. You have to set up a network of good quality stations, etc. But that probably becomes secondary. But I think those two are more important for having an operational, useful, effective forecasting system in the region.
Yeah, thank you. All these challenges. So there are a couple of questions here about hydropower projects. I think people are considering especially with your picture of the damage to a dam from the GLOF. I had to search for that. People are wondering about the future consequences of the many small hydropower projects, and also is there some sort of plan or map or something for comparing risks for dam safety for all dam locations and designs, so that the safer ones have better chances to proceed?
Yes, thank you. Hydropower is very important for mountain countries because that's what they have in terms of energy resource, right? Most of those countries do not have fossil fuels. Of course, fossil fuel is also not good for climate change and environment. Hydropower is clean energy. So there's a lot of expectation in the countries to utilize the hydropower potential and create economic benefits. But then there are a lot of challenges. I'll not go into many other challenges, but I'll just limit to environmental challenges. And one, I have clearly shown the impacts of glacial lake outburst floods. And other kinds of floods, landslides are also very, very important for hydropower and can negatively impact. Most of the hydropower in the mountainous part of this region are vulnerable to glacial lake outburst floods. And we have done, to answer your question, we have done mapping of all the glacial lakes in the region and also identified potentially dangerous glacial lakes, which means glacial lakes which could burst out in the future. That gives you an opportunity to do the risk analysis for hydropower. So see if there is a big, potentially dangerous glacial lake on the upstream of the site, and do some scenarios of outburst flood. If a block happens, what could be the impact? And that gives you a chance to, rethink about the location of the hydropower, the design of the hydropower and the dam, and make it safe against the hydropower, or do something in the upstream so that the flood actually, attenuates heavily before it reaches the dam. So there are many ways to do that, but I think risk analysis is very important. We are very much working, ICIMOD is working on this issue of sustainable hydropower, because, it's not only about environment, it's also about, social justice, right? There is a lot of inundation issues, relocation issues, market is another one, benefit sharing is another one, because, you develop hydropower in the mountains, but who uses the hydropower energy is the industrial areas and urban centers. So I think there is a big social justice issue also. So we are working under the umbrella of sustainable hydropower and see how those issues can be addressed. One key factor is environmental impacts. Yeah.
Thank you. Now, going back to the sort of community focus, I mean, I was very impressed looking at ICIMOD's website, and I'd recommend it to anyone attending to have a quick Google of ICIMOD and have a read of what's there, because it's very impressive. Someone has asked about smallholders of the region. What can they do to prepare themselves to manage water scarcity? And do you have examples of people migrating because of lack of water for irrigation? And what measures do you suggest will help people stay in the village and stay working in agriculture? But please take that further if you want to, in terms of the impacts and really the scale of this, the way in which this problem is going to impact mountain communities.
Yes, right. I mean, as I try to explain, in the real upstream part and mid-hills where there is no glacier and snow cover, the changes are quite impactful. And as you have said, the extreme is people are actually migrating. These are called climate refugees. Not so many, but could be more in the future. Right now, mostly migration is because of mixed things. Climate stresses, environmental stresses, but mostly economic, angle is there. But in the future, it could be more from climatic and environmental reason. So in those regions, of course, people are largely impacted, and in most places, because of migration, it is mostly women and children who are left behind, who have to face with the consequences of having difficulty in accessing water, reduced amount of water, and water not being available when and where it used to be available in the past, right? So that's a common issues. I showed one example of the irrigation canal drying out in Pasu, where it's a big problem of water availability. There are a number of things which can be done, and we are doing also, and there are a number of other, we are not alone, there are many other institutions who have done great things trying to help out in adapting to those changes and building the resilience of those people living in the mountains. So just a few examples is water harvesting, for example, right? Water harvesting at small scale is very important for mountains. And water harvesting can be done through small ponds. And those ponds can be utilized for accessing water when they need, when it is arid. But also those ponds, if placed properly, carefully, it can recharge the groundwater and actually supply water to the springs and makes springs work longer, and people can access water from the spring. And there could be some very simple technological interventions which can help people access better water. Some examples I can say which we have done in Pakistan, upstream part of Pakistan, is utilizing solar water pumps, which is not a very new technology. In the plains, it is very widely used, actually sometimes excessively used, and could also impact the groundwater there. But in mountain, it is not so much used. So we have kind of piloted those in upstream part of Pakistan, upper Indus Basin, and it has proved to be quite a good technology. Some challenges because of sediments and other things are there, but that can be managed. There is one simple device called Hydrograph, which uses the flowing water with the head and supplies water upstream, small amount of water, which has been very effective in those same areas. There are many different things that can be done. Simple climate services which can link with meteorological, forecasting and tell farmers what is likely to be the weather of tomorrow, day after tomorrow, and what they should do with their crops, and also if they should, harvest their, vegetables or not, or should they plan to go to the market with their vegetable or not, can also be very helpful. So there are a number of things that can be done to help farmers. Yes.
Yeah, it's very imaginative and creative thinking that's required. Just going back to the whole estimation question, I'm sorry to sort of zigzag, but questions don't come through in order. Vivek has asked, is glacial melt being quantified or delineated based on clean ice surface only, or is debris cover also considered? How were these challenges faced in view of overall underestimation of glacial melt?
Thank you. I think what I would say is that it all depends on the scale. If it is a small scale modeling exercise, we can go really into the details and try to differentiate clean ice and debris covered ice. Although there is a lot of limitation in terms of process understanding the ice melt under debris cover versus clean ice melt, depending on the debris cover thickness and materials. There are a lot of uncertainty there, but one can attempt to do if it is a small scale catchment scale study. But now if you go to a regional study like what I have shown, it would be really difficult and challenging to do that. There is a lot of approximation going on in terms of, representing the glacier. The way the glacier is represented is also a lot of approximation goes there. So there, I think it will be very difficult to differentiate melt process under debris cover or clean ice. So I think what has to be taken from the results is definitely with the understanding there are a lot of uncertainties. But when we look at different results coming out of independent researchers, it is more or less the same. So the dominating process, the dominating change in direction is more or less the same, right? So I think, again, I would like to repeat, these changes at broad scale will help us make decision, but then it would definitely be good, as you have indicated, go deeper into, more detailed process understanding, what happens with debris cover, what happens with clean ice, sublimation, etc., etc. Definitely.
Thank you. Yeah, ever complex.
Yeah.
Vinny has asked, this is just a completely different direction, have you studied any impacts on wildlife in the Hindu Kush Himalaya?
Not me personally, but our institution has a very strong ecosystem group. Mm-hmm. Also, I mean, basically they are looking at that living sphere, plants and animals, of course, and looking at the impacts on those entities. But whatever we do, and so the answer, Vinny, yes. But whatever we do, we always try to link it with people, right? If there is no people, for ICIMOD at least, we do not take it as an issue. So always, forests, rangeland, other ecosystem, how it interacts with people, how people interact with those ecosystems, and how it can be managed, because you cannot separate out people and ecosystem. So, yeah. But yes, the answer is yes. But I think we definitely have much more opportunities to link the climate, cryosphere, water with ecosystem, and that's the direction we are also taking in our institution.
Now, there's a very specific question here about the hydrographs on the Kabul River Basin. Mir Ahmad says that you mentioned the current hydrograph and the 2050 projection. Hydrographs are quite similar and don't change a lot. Does it mean that no change will happen in the glacial melt and the rainfall? So he or she is just asking about that hydrograph.
Do you see my screen? Not yet,
yes,
right?
Yes, we can see.
You can see my screen. Okay. So let me just blow it up. Oh, sorry. Let me go back. Give me a few seconds and I'll go back to the slide.
Thank you.
Yeah. Oh, just missed that. Okay, yeah. Right. So this is Kabul, right?
Mm-hmm.
This is Kabul under 4.5, RCP 4.5, which is the moderate climate change scenario. And this is Kabul under extreme scenario. So if last time I didn't go into detail, so let me do it now. If you see the components now, right? For Kabul, what do you think is the dominant, source of water? It is not actually glacier. It is actually snow melt, right? And if you are from that region, I think you will know that Afghanistan, particularly Kabul River Basin, does not have that large glaciers. The area of glacier is quite low. The water is predominantly from snow and rain. So that is what is very important. So for this moderate scenario, there is not much. You can see the error bars, that's the uncertainty. Within that uncertainty limit, there is not a big difference. Now, if we go to RCP 8.5, which is extreme, then you can see for the month of, starting from spring, April, May, June, July, and August, right? These are the peak seasons. Then you can see certain difference between the blue and red line. The blue is the reference period, current period, and then the red is future, middle of the century period. So you can see that future will be less during those months, although still within the uncertainty limit, but the departure is more significant than in the case of 4.5. So there will be less water during those peak period. So this is a peak period. So whether this matters or not, I do not know, maybe not. But in the shoulder season, when there is less water, the departure is not that significant, right? So probably it is not going to be that impactful, but changes are happening in those months. And the question could be why? And I think that's because of warming and having less snowfall, more liquid precipitation in terms of rainfall. But that is my opinion. I don't know exactly what's happening because this is a very detailed, case-specific, site-specific, question which needs further investigation.
Thank you. Now we're down to we're close to the end. We've been going for nearly an hour, so I'm just going to wrap up by asking you a sort of a bundled question, because a number of people have asked further questions about transboundary cooperation and regional cooperation on risk reduction and benefit sharing. How much cooperation is really happening? Do you think that ICIMOD can host a river basin commission, or river basin commissions, or advocate for new treaties? Perhaps you could just hold forth on that for a minute, and then we'll wrap up. Thank you.
What would you like me to do? Answer those questions? Or?
Yes, I think it was just about, in general, have you got some wrap-up conclusions about the prospects for cooperation in the region?
Right. Well, if we do not see prospect for cooperation, then I think that would question our very existence. I think if we go back to the mission of ICIMOD, it is about improving the life and livelihood of people in the mountains through knowledge generation and regional cooperation. So the mechanism is knowledge generation and regional cooperation. So we very strongly believe that cooperation is important. And the HIMAP report that I showed in the very beginning, it has come up with 6 call to action in different areas. One important call to action is regional cooperation to solve all those issues: risk management, benefit sharing, you have said, power sharing, energy sharing, all those. I think without cooperation, it cannot happen. So sooner or later, cooperation is needed. And our approach, as I've said, is through science. We will continue to generate science, but not only generate science and publish in high impact, journals, but also, engage with policymakers, decision makers, politicians in the region, and try to, sensitize them, make them, aware of those changes, and make them, feel that, change has to happen.
Yeah.
One beneficial position we have is that being an intergovernmental, institution, our board of governors are government people, but also we have independent scientists in our board, but we have the government representatives. So they can also take up those messages back to the countries and try. It's a slow process. It will take time, but I think we should really work towards this. I think without that, I don't think anything will happen. And I personally believe that, the world will be different in the future. And there will be more cooperation, more harmony, more sharing in the future.
Arun, that's just wonderful. And, I think the problems that you tackle in that huge region, dwarf everything that everyone else is trying to consider. And it's lovely to hear that optimism. On behalf of all of us, thank you again for your time and your wisdom, and for helping us to appreciate a bit more about the world's 3rd pole under climate change. And people who are attending, we're just closing up now. Please remember to check the IceWarm Australian Water School website for future events. And thank you very much, everybody, for joining us today and for your fantastic questions, which have ranged so widely. Thank you.
Thank you from my side to IceWarm and all who have attended. Thank you so much.
Subscribe to this YouTube channel by clicking the subscription button. For future webinars and online short courses, please visit our website at australianwaterschool.com.au.